Assalamu alaikum. I am truly excited to share with you one of the most popular and easy to understand topic in machine learning. This is the decision tree algorithm. My name is MD Shakhaudashan Chaudhary Shubho. My ID is 12108014. Today I will take you through what decision trees are, how they work step by step with real life example, their advantages, limitations and real world applications. Let's dive in. So what exactly a decision tree is? Imagine you are deciding whether to walk or take the bus to college. You ask yourself several questions. What is the weather like? Am I feeling hungry? Do I have enough time? A decision tree works in exactly in the same way. It is the supervised machine learning algorithm that creates a tree-like structure and makes decisions. It learns from past level data and predicts outcome for new data. It is used for both classification and regression. The biggest advantage is that it is very easy to understand and looks like a simple flowchart that even a non-technical person can follow. Before we go deeper, let's understand the main building block of a decision tree. At the very top, we have the root node. This is like the starting point of the whole tree, representing the entire dataset. Then we have decision nodes. These are the internal points where the algorithm makes the question or split based on features. The lines connecting these nodes are called the branches. They represent the possible answers like yes or no or different categories. Finally, at the bottom, we have leaf nodes. These are the endpoints and give us the final prediction or classification such as pass or fail. Now the question is, how does the computer actually build this tree? It follows a smart recursive process. First, it selects the best feature to split the data. Then it divides the dataset based on that feature. It calculates the impurity, basically how mixed or confused the data in each group. It represents the splitting processes again and again on the new subgroups. It stops when the data in a group becomes completely pure or when it reaches the maximum allowed depth of the tree. This process is very similar to how we humans solve problems by repeatedly asking better and better questions. Let me explain everything with a practical example. Suppose we want to predict whether a student will pass or fail in the exam. We have data of 8 students. Out of them, 5 passed and 3 failed. The first step is to calculate the entropy. Entropy measures how impure or mixed our data is. In this case, the entropy of the whole dataset is approximately 0.95. Next, we need to decide which feature should be the root node, study hours or attendance. To decide this, we calculate something called information gain for each feature. The feature with the highest information gain becomes the root node. When we split by study hours, we get very good separation. High study hours means all students pass and this is pure. For low study hours, all students fail. This is also pure. For medium study hours, we can see mixed data. The information gain is 0.61, that is quite high. This means study hours is very good feature to split on. Now let's compare it with attendance. When we split by attendance, good attendance group is entropy is 0.72. For poor attendance group, entropy is 0.91. After taking the weighted average, the remaining entropy is 0.79. So the information gain for attendance is 0.16, which is much lower than study hours. This clearly shows that study hours is much better feature to split the data fast. After comparing both features, we can see that study hours give significantly higher information gain, 0.61 versus 0.16. Therefore, we chose study hours as the root node of the decision tree. This is the most important part of the decision tree building, choosing the best starting point. After the first splitting, our tree looks like this. After making the first split on study hours, we get three branches. High study hours, all students passed. This branch is pure, so we make a leaf node saying yes or pass. For low study hours, all students failed. This is also pure, so leaf node is no or fail. For medium study hours, it is still mixed. We have both yes and no cases here. So we need to do another split using another feature, in this case attendance. For the medium group, we use attendance to split further. Good attendance means pass and poor attendance result to fail. And here is our final decision tree. Beautiful and easy to understand. Decision trees are not just for classrooms, they are widely used for real world. In hospitals, doctors use them for medical diagnosis, predicting diseases from symptoms and test results. Banks use them for loan approval to assess whether a person is likely to repay the loan or not. Email services use them to detect spam messages, and financial companies use them for fraud detection to catch suspicious transactions in real time. Their biggest strength is that they are easy to explain to managers, doctors, and regulators. Like every algorithm, decision trees also have strengths and weaknesses. Its advantages are it is extremely easy to interpret and visualize. It can handle both numerical and categorical data. There is no need for feature scaling or normalization. It can capture nonlinear relationships. It can work even when some data is missing. Its some limitations are it can easily overfit, especially if the tree becomes too deep. A small change in data can sometimes create a completely different tree. They can be biased toward features with more categories. They are not always most accurate when used alone. Because of these limitations, we often combine many decision trees to create more powerful models like random forest. In conclusion, decision trees are powerful yet simple machine learning algorithms. They mimic human decision making process and are very easy to understand and require very little data preprocessing. They give us clear insights about which features are most important, and they also serve as the foundation for more advanced techniques like random forest or gradient boosting. Thank you so much everyone for listening so attentively. I really appreciate your time. Now I would love to hear your thoughts and answer any question you may have. Please feel free to ask anything.